Welcome back. Today we're going to talk about data processing for a population sample. Let's say we were looking outside and we had this sample population and we wanted to process the data about the different types of organisms that were in that sample. The first thing we want to do is talk about the different equations we would use to process that data. So a few of the things that we can look at are density, relative density, frequency, and relative frequency. Now, of these four things, we want to look at, let's say, one specific organism. So let's say we want to look at this organism here. Let's just refer to this right now as organism A. So we'd say the density of organism A is equal to the number of individuals divided by the area of the sample. The relative density of species A is equal to the density of species A divided by the total density of all species times 100. The frequency is the number of plots with species A divided by the total number of plots sampled. And again, we carry that number down to calculate our relative frequency, which is the frequency of species A divided by the total frequency of all species times 100. So once you've gathered your population sample, you're going to come up with some numbers like this. So we've tested out 6 different quadrants here, and in these quadrants we're able to count the number of total organisms, the total individuals in each of those areas. Now what we're going to do is we're going to process some of this data, but what I'm going to do is process mainly here for the woodlouse, and and then fill in the details into a data table for the other 4 organisms in that area. So we want to start by calculating the density of the woodlouse here. And in order to get the density of the woodlouse, let's call that species A, we need to take the total number of the species. And in this case, we want to get the area of that species, but we need to take the number of quadrants we sampled, which is 6, times the area of one quadrant, which is 0.0009 meters squared. And we can find out that the density of species A equals approximately 1,667 organisms per meter squared. So if we had a square meter, we would expect to find over 1,000 of those woodlouse in that area. So we can fill that in now. We'll fill this into our bigger table here. So the density of the woodlouse is 1,667 per meter squared. Now I'm going to fill in these other boxes just to move on to relative density. So we would expect to find approximately 7,592 organisms in every square meter. That would be the total of these 5 from our population sample. Our relative density from the equation above for organism A was taking the density of this species, which is 1,667 per meter squared, divided by the total density of all the species, so 7,592 per meter squared. The meters squared cancel out, and then we need to multiply our answer by 100. So the relative density for A equals 21.96%. So that's the relative density of organism A. So we can put that down here is 21.96%. And of course, when you total these up, you should get approximately 100%. The next thing we want to do is calculate the frequency of species A. So if we take the frequency of species A, we're going to take the total number of plots with species A divided by the total number of plots sampled. So if we go back to our data, we've sampled 6 plots, and we found species A in 6 plots, and we did a total number of plots being 6, that we get an answer of 1. If we have an answer close to 1, we can expect to find it in every plot that we sample. As the number gets closer to 0, we would expect to find it in no plots. And something in between there, if we get 0.5, we would expect to find it in half of the plots that we sample. So the frequency of species A is 1, which means we can find it in, or we would expect to find it in all plots that we sample. So if we go ahead with our total frequency, we can see, just to use this later on, we would have 2.49 as the total for all these. To find the relative frequency of species A, we need to take the number of plots with that species. So the frequency of that species gets carried over to there. We divide it by the total of all of the frequencies of these different organisms, and we multiply it by 100. And that gives us a relative frequency of species A equal to about 40.2%. So let's fill this in here, 40.2%. So what I'm going to do again is fill in the rest of this chart and give us our total at the end. So when we look at the relative frequency, we really need to compare these percentages to the other organisms, and we can see that the woodlouse and the leaf, you're going to find them a lot more often or a lot more frequently compared to the springtail or false scorpion, and you don't really expect to find the centipede at any point in time. If we take this information and we want to graph our results, we can make some pretty simple graphs here. For example, let's say we wanted to plot the density of organisms in a 1 meter squared sample. I think I would probably select a simple bar graph for this example, and again, just kind of keep this real basic as we look at our overall sample here. Let's say we have 1,000, and basically on this side we're going to talk about the numbers of organisms, and on the bottom we're looking at the specific species that we talked about earlier. And again, let's keep this simple here. We've got the woodlouse, the centipede, the false scorpion, the springtail, and the leaf. And so if we just simply kind of charted all these out here, we would say the woodlouse had approximately 1,667. The centipede was at 0. The false scorpion we estimated around 185. The springtail was around 555. And the leaf was around 5,185. Ooh, it's a little crooked. Okay, and normally we wouldn't want to go off our chart, so we would assume we're extending this up to approximately 6,000. Now, if we want to do graph number 2, if we want to look at the relative density, a 1 square meter sample, in this case we could simply start by making a pie chart. So almost 70% of this overall population, so roughly 68% we calculated before in this situation, was made up of our leaves. Approximately 20% of the population in this case was made up of the woodlouse, and then the remaining 10% we had, about 2.4% was here in the false scorpions. So we had here about 2.4% was our false scorpion, and then this remaining 7.7% we said was our springtail. So again, you could calculate relative density or frequency and chart either of those things as well. Overall, this is just presenting a summary of ways that you can process population data within a population. I hope you learned something new today.